Welcome to the GCSE Maths Advantage. I'm Dr. James Carter, and every episode I'm going to break down one topic, show you where the marks are, and give you a quick win you can use in your next exam, whether you're targeting a grade 7 or pushing for a 9. Let's get into it.
Hook. This one question lost more marks than any other on last year's papers. A simple transformation where students put a +3 where a -3 should be, and suddenly a clear 3 marks disappeared. Sound familiar? If small sign errors have ever cost you a question, this episode is for you. I'm going to give you a predictable 4-step routine so you stop guessing and start getting those marks back.
I remember that. I sketched a parabola the wrong way, and my teacher told me the shift was backwards. I still can't quite explain why the sign flips for horizontal moves.
Perfect. That's exactly what we'll fix. Section 1. The concept. We'll keep it simple and visual. First, every transformation problem starts with the parent function. Say the question gives y equals x minus 1 squared plus 2. The parent is y equals x squared. Always say that out loud or write it down. The examiner loves it. Parent function y equals x squared is a sentence that wins you method marks early.
Step 1 of the routine. Identify the parent function and a neat starting point, a point on the parent that you can track. For y equals x squared, a natural point is 0, 0. Step 2. Apply horizontal changes first. If you see x minus 1, that means a horizontal shift to the right by 1. Important phrasing to write in the exam. Translate 1 unit right.
Wait, so why is it x minus 1 that moves right? It feels backward because you'd think minus means left.
Great question. Here's the why. The expression x minus 1 means plug in x minus 1 for x. To make the original x value produce the same output, you must increase x by 1. In effect, every input is delayed by 1 unit, so the graph shifts right. In spoken exam language, you're replacing x by x minus 1, so the graph must move 1 unit in the positive x direction. The sign in the bracket is opposite to the movement. That's the classic trap.
Step 3. Apply vertical changes next. After you translate horizontally, apply any vertical shifts like +2 or -3. Those are straightforward. Add moves up, subtract moves down. Step 4. Handle stretches and reflections. A multiplier outside the function, like 2 times f of x, is a vertical stretch by factor 2 from the x-axis. A multiplier inside, f of 2x, compresses horizontally by factor 1/2. Note and say which axis the scale is from. That's the reason students mix up scaling errors.
So horizontal changes inside the brackets, vertical outside, and do horizontal first. Got it. But what about reflections? How do I spot them quickly?
Reflections come from a negative sign. Minus f of x reflects in the x-axis. F of minus x reflects in the y-axis. Again, say it. Reflect in the y-axis or reflect in the x-axis. Saying it as you sketch reduces mistakes and shows the examiner you understand the operation.
Let's move to section 2, worked examples and common mistakes. Example 1. Sketch y equals 2x plus 3 minus 1, where we treat the inside as linear. Routine first. Parent function, y equals x. Write it down. Identify horizontal change. X plus 3 is a shift left 3. Remember the sign flip. Then vertical. -1 is down 1. Then stretch. The 2 multiplies the whole function, so it's a vertical stretch by factor 2. Now pick a test point. The parent point x equals 0 gives y equals 0. Transform it. X becomes -3, y becomes -1, then stretched to y equals -2. So 0, 0 maps to -3, -2. Plot that and use it to anchor your sketch.
I always used 1, 1 for a line, but 0 simpler. Testing a single point like that makes the shifted coordinates clearer.
Exactly. Common mistake here. Students write the horizontal shift as +3 instead of left 3,
or they stretch the x values instead of the y values. Examiner-friendly phrasing to include parent function y equals x, translate 3 units left, then vertically shift down 1, then apply vertical stretch factor 2, tested point 0, 0 to -3, -2. That short paragraph often secures a method mark even if the sketch is slightly messy.
Example 2. Quadratic. Sketch y equals x minus 2 all squared plus 3. Say, parent y equals x squared. Horizontal, x minus 2, right 2. Vertical, plus 3, up 3. No stretch. Test the vertex. Parent vertex, 0, 0, becomes 2, 3. Mark the vertex clearly and draw a symmetrical parabola. The big slip here is forgetting to label scales, or to show the vertex coordinates. Labelling is cheap and earns accuracy marks.
What about reciprocals and asymptotes? I lose marks on those.
Good point. For reciprocal functions, like y equals 1 over x plus 2 minus 1, always state asymptotes. Parent y equals 1 over x has vertical asymptote x equals 0 and horizontal asymptote y equals 0. Apply horizontal shift inside. X plus 2, shift left 2, so vertical asymptote moves to x equals minus 2. Vertical shift of minus 1 moves horizontal asymptote to y equals minus 1. Write those asymptotes explicitly. Vertical asymptote x equals minus 2. Horizontal asymptote y equals minus 1. Students who miss asymptotes often lose the final accuracy mark on these questions.
Section 3. The exam technique. How the marks are awarded and what to write. Most graph transformation questions break down like this. M1 for correct setup or stating the parent function and the first transformation, M1 for showing the transformed sketch or transformed algebra, and A1 for correct labelling or final answer. For a 3-mark question, you can often secure 2 marks quickly by writing the parent function and a short sentence, translate to right, shift up 3, before you sketch. That way, if your sketch is slightly off, the examiner sees your method.
So, even if my sketch is a bit rough, I should write the steps first to get the M marks?
Yes, write the steps, then sketch. Use examiner language. Parent, y equals x squared. Translate 2 right, translate 3 up. Short, precise statements are gold. Partial credit strategy. If stuck, at least transform and write where 3 key points go. For a parabola, use 0, 0, 1, 1, minus 1, 1, or the vertex. For a reciprocal, name the asymptotes and map 1 point per branch. Those pieces often earn method marks, even if you can't finish.
Also, label the axes and choose a scale. Examiners penalise unlabelled axes or inconsistent scales. If the stretch makes the graph steeper, show that with a few marked points rather than guesswork. Write the transformed coordinates next to your points. It's evidence of correct method. Quick win. A 90-second routine you can use in every practice paper. I call it parent, horizontal, vertical, test. Say it out loud as you read the question. 1. Write the parent function. 2. Apply horizontal changes and state them, left, right. Say, remember the sign flips. 3. Apply vertical changes and any stretches or reflections. Say which axis the stretch is from. 4. Test 1 point and write the transformed coordinates on the sketch. Finally, label axes and any asymptotes and box your final vertex or asymptote equations.
I can try that now. Parent y equals x squared. Horizontal, x plus 1, so left 1. Vertical, minus 2, so down 2. Test point, 0, 0, to minus 1, minus 2. Label axes. That only took a few seconds and makes the sketch much faster.
Exactly. Do that on every transformation question. Make it a habit. That's your quick win for today. Test a point and label everything. It catches most small sign and scale errors.
CTA. If you want 2 practice questions per topic with worked solutions and a marker checklist for transformations, visit jcacademyonline.co.uk.
There's a downloadable sheet that matches the 4-step routine and gives you exam-style practice to build the habit.
In one sentence, identify the parent, do horizontal first, vertical next, then test a point and label your axes. If this helped, share it with a friend who's revising. You'll find more worked solutions and revision resources at jcacademyonline.co.uk. Until next time, trust the process and nail that exam. Stay curious.